Welcome back to another episode of Flawless Plan Garage, where today we are doing something a little bit different. We are tearing down a 2.5 liter Duratec that has had kind of a rough go in my Locost 7. We're also going to take a look at just kind of what it takes and what I had to do to this motor to make it fit in a rear-wheel drive kit car? Caterham? Lotus 7? Whatever you want to call it. I struggle to know what to call the thing. It's a completely scratch-built car that is street legal, although its main purpose is to scare me on the racetrack. And as we saw last time, this has a fairly significant issue with leak down and ability to hold compression for sure in the cylinders. So we're going to tear it down, see what's broken, and also kind of give you a tour of what it takes to set one of these up to run in a car like this. Stay tuned. Ignition. Worth a quick conversation. Certainly in a normal circumstance, I could have probably continued to run, and some guys in the low-cost community will run, like the stock engine computer and everything on the Duratec, especially if you're not running this version of the engine. I chose to run Mega Squirt on mine, and I'm running the old school Ford EDIS 4 ignition system, kind of triggered by the Mega Squirt. So very simple setup, cheap, easy to put together, and I just made a little bracket here on the back, which bolts essentially kind of to the back side of the head and has cracked several times. The downside to the 2.5 liter, especially when you've peeled the balance shafts off the bottom, as we'll take a look at here in a few minutes, is that it vibrates. I mean, it vibrates. And it's hard on everything. It's hard on the driver. It's hard on the rest of the chassis of the car and brackets that you bolt to it and everything else. Now here on the driver's side of the engine, the first thing we'll talk about is the intake. So I chose to make a fairly significant change from the stock intake and went to a motorcycle individual throttle body setup. This is off of a Suzuki GSX 750R, I believe. I think the 750 to the 1000Rs are all the same. I plugged, as you might be able to see in here, I plugged the fuel injector holes that were in the original motorcycle throttle bodies. Then this manifold adapter I was able to purchase used from someone who had abandoned their project. I believe you can also get manifold adapters to the Duratec from Dan ST Engineering in the UK. I'll leave a link in the description below to his website. Then this piece here, the filter adapter, set up to mount onto these motorcycle throttle bodies. And there are some trumpets inside. We'll take a quick look at. This also came from Dan ST Engineering. Was really happy with the quality of his work, the pieces that he makes, and the prices, not cheap, but not obscene for custom stuff that you're getting. Then this piece here, because the manifold that I have is for a 2.3 Duratec, the 2.5 Duratec has significantly larger intake ports. And so this adapter adapts the 2.3 to the 2.5 size ports. Whether that really helps, I don't really know. I have continuously had problems getting this all to seal. So I have, you can see here, added layers of gasket material just trying to get the thing to seal. And my biggest issue has been getting it to seal at idle. If you've seen any of my videos where I'm driving the Locost, once it's hot, once it's up to operating temperature and at idle, there's this whistling sound all the time, and that is it pulling air around this intake manifold base gasket. And I think the real issue is just how few bolts you actually get to seal the thing with. So there's no tapped hole here in the head, so you only get 2, 3, 4, 5, maybe 6, something like that. Like, you just don't get very many bolts to actually get good clamping force, especially when you have a sandwich of the adapter and the manifold together. So that's been kind of an issue for me. Also, you've got to be able to get the coolant The stock, water manifold is on the back side, what is now the back side of the engine. And you've got to get that coolant around front to the radiator somehow. So this is like a coolant bypass tube that I made. I made this out of steel exhaust tubing. You might want to be a little careful about mixing steel and aluminum in a cooling system because of the galvanic issues. You actually can create voltage and rust when flowing water through differing materials like this. When you've got like an aluminum engine block, aluminum head, aluminum radiator, but a steel pipe here. But so far it's been okay. Realistically, I just don't do that many miles on this car. It should last a long time before anything rusts out and falls apart. So far this has worked out well for me, except for one really dumb mistake that I made in just the layout of the coolant pipes. I misread the way the coolant was flowing in this engine, and so I'm actually flowing water through the radiator backwards. Yeah, I thought this is the thermostat housing here, and I had thought the thermostat housing was the outlet for some reason, so that goes to the top of the radiator, and then it kind of flows down and across, and then back into this tube. That's incorrect. This is the inlet to the motor. This is where the outlet is. So right now I'm pumping water out into the bottom of the radiator, then it has to come up and across, and then into this tube to come back in. So, but especially running E85 on the track, it does not overheat. So, okay, I guess. Fuel injectors, which have been the bane of my existence so far. Running this on E85, I've had continual problems with the first batch of fuel injectors that I bought, and I believe the fuel injectors are what have killed this engine. When I had fuel injector failures, I think I probably had cylinders going lean individually, and I'm assuming that we're going to find broken rings, ring lands, that kind of thing when we tear this motor apart. These are just Bosch EV14 550cc injectors rated for E85 with a stock fuel rail. I did this because I wanted to make more power, wanted to run it on E85, and tuned and ran fine, but I just had issues with them failing despite being rated for the corn juice. So we'll see if my latest batch holds up better. Custom mounts. These were actually purchased as kind of a knockdown kit. So I had a nice thick, probably 3/8 of an inch thick or so flange piece that is set up already drilled and already cut to fit the Duratec block. And then some pieces of tube steel, some other pieces of tube steel, some shackle bushings. And then you just kind of cut it to size and weld it up for your application. You can see also in this case, I notched it a little bit to fit the oil dipstick tube, which is a soft piece of rubber. We will get to see that when we flip the thing over a little bit. The most expensive part of this whole build, putting this engine together, was this oil pan. And that also necessitated this dipstick tube. We'll get into that in a minute. Then this oil filter adapter. I did not have room for the stock oil filter and filter adapter because I have a frame rail that goes right there. So I was able to find this little oil filter adapter that goes to some AN fittings. It has some big NPT fittings, and then you can adapt to an AN. And that way it makes it easy for me to run an external filter. And I run a big old Chevy small block filter adapter, filter and adapter that I mounted elsewhere on the frame. So here on the front of the motor, you can see I've got that small alternator. I just fabricated some brackets out of some plate steel to mount the alternator down low rather than the stock location, which I think was over here, if I remember correctly. Then this adapter here, I don't quite recall if this was stock on this version of the engine. I don't think it was. I think I had to get the toothed wheel off of a different version of the Duratec so that I could run the simple little, Hall effect sensor to pick up the missing tooth and use that to fire the Mega Squirt. Then keeping the stock water pump and the stock belt tensioner, and just a nice, really simple, clean, effective front end when you don't need power steering or that kind of stuff. So this made it easy, made it simple. Still get to keep a stock tensioner. This has worked really well. 1320 millimeter belt is what ended up working out for me, but that's just because of the size of the pulley that's on this and the size of the brackets that I made. I also made it with a slider and some adjustment there, but this worked out well. You can also see my fancy little timing mark, little piece of copper wire. It was useful just when getting everything set up to mark TDC, since this timing cover doesn't actually have TDC marked on it anywhere for cylinder 1 for checking timing. So that made an easy way to just check things while I was getting everything set up. Okay, another Duratec tip. The 2.5 has variable cam timing, and I didn't want that because I couldn't run it with the old Megasquirt version that I'm using. That variable cam timing solenoid goes right here and actually sticks through the valve cover. And I knew that, I wanted aftermarket cams, I didn't want variable timing control, and so I was going to get rid of that. So this valve cover is off of a different version of the Duratec. I don't remember which version this is from. It's probably from like a 2.3 non-variable valve timing, maybe out of a Ranger, something like that. Works fine, doesn't have the hole, which is good, which is what I wanted, but also the downside is it doesn't have a dipstick tube in it. So, because it was set up probably for the Ranger, which has a dipstick tube on the other side. So, just something to be aware of if you're looking for one of these. Be aware of whether you have a dipstick tube or not. That forced me to go external over here, which is fine. Now let's have a look at how the cylinder head looks here. Overall, things look real good in here though. So my other change that I did, as I mentioned, I wanted to do away with the variable valve timing. This engine is out of the hybrid variant, runs a 12.3 to 1 static compression ratio. And the reason they can get away with that is that in the hybrid, they run the motor in the Atkinson cycle, where you get a lot of overlap on the intake cam especially. And so the dynamic compression ratio is actually much lower than that static 12.3. I was going to switch to these are Crowder, I believe they called them like their stage 2 cam. I don't remember the specs. If I can find them, I'll link them in the description below. Not a super aggressive camshaft, but I wanted something more aggressive than stock, a little more power and a little more power up top than stock. So went to these. They have no variable timing component. And they also, obviously don't reduce the dynamic compression nearly as much as those stock cams do that run on the Atkinson cycle. Another change is that these only have that like single pickup. They don't really have a pickup back here for the stock cam sensor. So the stock cam sensor is here, and the normal 2.5 Duratec camshaft has like multiple elements back here for this to pick up so that it can sense whether or not it's phasing the cam properly. These Crowder cams don't have that, so that's just one more thing. You'll notice, if you notice the wiring on mine, that I don't even have that cam sensor hooked up because I can't, there's nothing really here for it to read anyway. I also have aftermarket Crowder springs and retainers down underneath. Just wanted to make sure things were solid for working with these cams. The one thing I would like to double check, I never took the head off. So I never checked the piston to valve clearance. I don't think that was really a problem. I don't think it would have run as well for as long as it did if I actually had a piston to valve clearance issue. Also, I don't think my current failure is bent valves. But before I go buy another motor and slap in here and do this whole thing again with the same recipe, I kind of want to double check that. So we're going to take the head off and then take a quick look at seeing if we can mock up our piston to valve clearance. Here you can see the intake adapter is set up to use the stock rubber gaskets on the backside, which is cool. I don't think it was leaking from this side. I think it's always been leaking from this side. And you can also see here, man, respect to the Ford engineers who hogged out these intake ports. Like, those things are just gigantic in my mind. For a 2.5 liter engine, that is a big intake port. Nice and clean. Timing hardware all still looks good. So the other thing I had to change, obviously the stock cam had an enormous variable cam phaser here, so I had to buy a stock, however many teeth this is, cam gear from Ford. That was no big deal. I think I just bought another exhaust cam sprocket is what I did. Timing chain and everything, I did all that new when I put it together, which in all likelihood has only been a few hundred miles. Track car is not the greatest for longevity. This is part of the reason I wanted to be pretty aggressive about tearing down and potentially replacing this motor. You know, I've got $2,000 or $3,000 in parts bolted onto this $300 to $500 engine. So, you know, the engine long block, cylinder head, pistons, etc. are disposable, but I want to keep the cams, the oil pan. I don't want to break that stuff. So I don't want to let the engine get so bad that it circulates metal through the whole system and makes my expensive parts unusable. And yeah, so far, I mean, I don't see anywhere on these cams really, like even the journals are looking really good still, and the lobes, like I can't differentiate those from new. This is another important little piece here, and this is a little plug that eliminates the variable timing solenoid actuator thingamajigger. Well, no big time obvious damage on the piston tops. Try to turn it so you can see a little bit here. Obviously, we've got to find more coolant every time we move the thing. But the good news here is that there is definitely no indication of a piston to valve clearance issue. You know, I've got no marks, no clean spots, no divots, nothing like that showing on the pistons. So they don't appear to have suffered anything from the valves. And if they are missing a chunk of ringland or broken rings or anything, it's not obvious from the top side. The cylinder walls themselves, in 1 and 4, they look awfully good. Good crosshatch, okay crosshatch. Now the real piece de resistance in getting this thing to work properly in a Locost, for me, was this raceline oil pan. So this is a very flat, but still a wet sump oil pan. I didn't want to deal with dry sump because of the complexities of having to run the external oil pump and needing to find a place to put a giant external oil reservoir. So this was perfect for me. There are a decent number of guys with Caterhams and such in the UK that use these on the track and have served them well. Yeah, it was expensive. It was probably the most expensive single part that I put on. I want to say it was in the 700 or 800 euro range. Maybe that was dollars, pounds. I don't remember. It was a while ago, but it was expensive, quite a bit more expensive than the engine itself. Now, as expensive as this oil pan was, it is significantly lower profile, or gives a lot more ground clearance than my other options. And therefore, in a way, it's actually saving money, because I had a couple of Ford Ranger oil pans on here, which are about, if I recall, about 3 inches deeper. And that all comes out of ground clearance. This little hump, as an example, this is actually a bolt that comes through from the transmission bell housing into the oil pan. So technically, the transmission bell housing, it becomes the lowest point of the car. The Ranger, with its stock oil pan, like I said, is about 3 inches or so deeper than that. Now, I don't want to say that I was having ground clearance issues with that Ranger oil pan, but I destroyed 2 of them driving on the street. And it wasn't because I went over a speed bump or anything, it was just because of the crown of the road between, and some grooves where the tires go in the lanes. That was enough to grind off the oil pan. So I think the first one lasted about 1.5 miles, and the second one lasted about 15 miles after I raised the suspension some. So at that rate, that was going to get expensive very quickly. So this made a lot of sense. It completely transformed the usability of the car on the street. And because it was so expensive, I decided to protect that investment with this little guy. This gigantic steel plate, skid plate that I made to go between the frame rails and give me something else to hit first in the off chance that I did, have to go over a speed bump or something. And this has taken a few minor scrapes, But overall, even with this in place and with it running fairly low ground clearance in the suspension, I can actually ease my way over a speed bump, and normal street driving is no issue. It goes around great. And it only adds about 30 pounds of weight. You can see as well, this is really nicely baffled inside. It does a great job of oil control. It's a really, really nice quality piece. Again, no sponsorships, no nothing. Bought this a few years ago. Just really happy with it. Then here you can see, and unfortunately I had already scrapped some of those old pieces like the Ranger oil pan to show you for reference, and the balance shaft assembly. So normally you'd have a giant balance shaft assembly that goes here in the oil pan. It weighs about 19 pounds. So it's massive, it's serious, and it has a lot of work to do on this 2.5 because this is a lot of 4-cylinder slinging around. But yeah, it's gone now. You can actually see as well, I'll try and get a shot later to show you, there's when you delete the balance shaft, there's another little oil plug that you have to put in. But very simple to do. And like I said, the Raceline setup is really really nice way to convert to a much lower clearance oil pan. Although obviously you've got to get rid of the balance shafts. Now, I think that instead of testing piston to valve clearance, since I saw no evidence of issues with that, I think what I'm going to do is actually pop out one or two of the worst cylinders here. Just pop the pistons out and get a look at the rings and see if we can tell where the issues were there. Golly gee willikers. That bearing looks awesome. Okay, so I've just rinsed it off, but I've tried not to clean off any evidence of anything. So first of all, other than some remaining dirt from the garage floor, you can see we've got a little scoring on the skirt, but not bad. Again, on the other skirt, you know, a little scoring, but really nothing bad. You know, tear apart a Subaru EJ, an engine that has few mysteries left for me, and see much worse skirt wear than that, much faster. And I don't see any broken ring lands. You know, they look fine. The rings themselves, even, I don't see any broken pieces. I don't see any chunks missing or cracks, broken pieces. They don't seem to have been like really cooked and discolored or have lost their springiness. I don't know why we would see such ridiculously bad leak down numbers on this cylinder. I think it might be time to take a closer look at the cylinder head. Taking a look at the cylinder head here, we don't see any evidence of bent or damaged valves. They all look really good. A little dirt and something I was spraying over here earlier, but really they look pretty good. I also don't see any evidence of a compromised head gasket. You know, normally you would see some kind of burn marks between the cylinders if you've got exhaust or compression leaking between them. Don't see any evidence of that. To the naked eye, I don't see any cracks or anything of that nature. So not much to say here. Looks pretty good. The gasket itself also does not seem to have much to tell us. It's dirty. Got some rusty deposits from the coolant a little bit, but really overall, no evidence that I can see of a compromise. Well, my assumptions about the head may not have been completely correct. You see here what I've done is I have shot just some brake cleaner down into the intake ports. Way tough to see down in there, but there's a bunch of fluid in there to see if it would leak past the valves with them sitting closed like this. And it does. And it does. And it a little bit does. And it doesn't. So, remember cylinder 1 has no leak down issues. The rest of them do. This one has a little bit. This one has more. This one has most. I'll do this with the exhaust valves too, kind of dry it off and try that, but maybe I do have some valves leaking. Maybe that's the issue. Okay, and the exhaust side. This is the before. Let's shoot some liquid in there. Still can't really see it. Are we getting any seepage? Not really. It looks like, to the extent that I have issues, it's on the intake side and not the exhaust side. Now, I took this head to the shop, and even with the only having about 60 thou of piston to valve clearance, which is right down on the very bottom end of what anybody would say that you need, none of the valves are bent. They definitely were leaking, seeping, and he believes that was probably my leak down problem. But it's really just, worn out against the seats. It's just not sealed properly. Basically, it needs a valve job. I don't remember how many miles were on this engine when I bought it. I only put maybe 1,000 or 2,000 miles on it, but a significant number of those were on the track, and a non-trivial number of them were with an untuned Mega Squirt setup. So who knows what abuse this poor thing suffered in my hands. At any rate, good shop here in town that I really trust and appreciate. I've probably done 24 heads with that shop, but it's $300 or $400 to do a valve job because it's a lot of labor on these, or $260 for a whole new engine. So guess what I did? It's easy to forget sometimes that there are little parts that just make or break a build and even the possibility of a build ever working. One of them in this case is a pilot bearing. You can maybe just see down in there. So this is a T5 transmission with a custom bell housing to mate it up to the Duratec. But that, normally you wouldn't have a T5 going into the back of a Duratec. So that pilot bushing, or pilot bearing, excuse me, that goes on the inside of the crankshaft is critically important. Here is the old crankshaft where it was installed, and you can see here that I used the old grease method to remove it. So basically I packed a bunch of grease into the pilot bearing on the old motor, then took a rod, something that was the appropriate diameter, jammed it down in there. The hydraulic pressure then of forcing the grease down, and then the grease wants to come back up and around. That hydraulic pressure will force the old pilot bearing out of the crank, and incidentally also means that you get some nice grease into the pilot bearing again. So got that swapped over. That is a custom piece I had to get from England because you need the right inner diameter for the T5 and the right outer diameter for the Duratec crank. So that's not a stock part. But thankfully I was able to swap it over pretty easily with no damage. Then we have the clutch. So this is a, if I recall, a Ranger flywheel and also a Ranger clutch pressure plate, some cheapo aftermarket one. I have found that with a 1,500 pound car, it really doesn't matter because you don't, clutch doesn't work very hard, so it doesn't need to be anything too special. But then obviously you got to get it centered. And with my variety of centering tools, I apparently do not have one. I don't remember where I got this one, but apparently it's not quite right for the T5 because the diameter here is too big to fit in the pilot bearing, so it's bigger than this T5 transmission shaft. So I don't actually have a alignment tool that works. So I got it as close as I could, but that was not close enough, could not get the transmission mounted properly. So we're going for a new method. I'm going to loosen this up again, take another try at the alignment, and then as you can see, I have laid the engine on its face so that I can just drop the transmission straight down onto it. I think that'll be easier here working by myself. Struggling to hold the transmission up when trying to slide it on laterally wasn't working very well, so we're going to give this a try. Vertical drop. Fingers crossed. And we are back. New engine is in. The price on this motor actually was $260 plus a $100 core. So that was pretty cheap. It was going to cost about $400 to rebuild the head on the old motor, which was actually, you know, it's totally reasonable. I have no objections to that price, but when you can get a whole nother engine ready to drop in for less money, I figured I'd go with that. Now, that being said, going in here, as we noticed, the valve seals are in pretty bad shape. I didn't have new valve seals handy when I was switching the springs over, so I didn't put new seals in it, and these were not in very good shape. I have started and run this some, and it definitely smokes sometimes and uses a little oil. I did a leak down test on it after maybe just one cycle of just running it and making sure it was halfway okay. And there is some leak down on it as well. So it's entirely possible that the valves on this engine are not fantastic either. I think I had like 25 or 30% leak down on one cylinder. That wasn't a cold motor, other extenuating circumstances. So we're going to cross our fingers and hope for the best next time we have this one out. But it does work, and I will attempt to prove that. It'll run a lot better once it's warmed up, but it does work. Hopefully this is going to do the trick for now. I'm sure I'll break something on it soon enough. For that, I'll have to wait till next time. Thanks for watching.